Okay. Sorry that I didn't have energy to get up early and then drive to school. So recording and then just too much to do. I have to come back. So last time, before I even remember, I recorded the first half of chapter 9, where we do the hypothesis test. It's very similar to the previous chapter confidence interval, but the difference is, we have to set the hypothesis. And then depending on what our hypothesis is. So if our hypothesis is to prove, the average is different, okay, like in this case, the null hypothesis is mu equal to 1.8, and then the alternative hypothesis is mu not equal to 1.8. Then we will have two-tail test. So this will be similar to the confidence interval we did in the previous chapter. The first part, we have one-tail test. So the new hypothesis will be mu less equal to 8,000 hours. And then the alternative hypothesis is mu greater than 8,000 hours. So based on that, anything in this area, let me get a pen. So finally, I have a touch screen, so I can use my finger. So this area, if anything less here, then we do not reject the null hypothesis here, okay? We do not reject. Anything greater, then we reject. Okay, so you see, anything greater, we reject. Anything less equal, we don't reject. Okay, so this is the what we did last. I don't even know when I did it. It was, when was it? It was one day. Yeah, I don't remember what I needed to do. Oh, I need to fly to I flew to Pittsburgh. Yeah, I flew the private jet to Pittsburgh. Oh yeah, and then I recorded the I think on Sunday. Yeah. So and then this one is so very similar to what we did in chapter 9 confidence interval. So if we know population mean and we don't know the population standard deviation, then we use this one. Okay, then we use t statistics. So we will substitute the sample standard deviation S to replace the population standard deviation, which is sigma. Okay, so one example, the average cost of the hotel room in Chicago is claimed at least $188 per night. A travel agent thinks the price should be lower than $188. Okay, so the random sample, they picked 25 hotels, and then they found out of the 25 hotels, they asked the price. The average price is $177. This is oops. This should be here. It moved. Maybe when yeah, okay. So X bar should be 177.5, and then S, the sample standard deviation is 25.4. So we want to test whether or not this is lower. Okay. So remember, we have to set the hypothesis test. So the first we use the critical T value. So compare the critical T. Compare the T value, okay? But the hypothesis is we think the average cost is 188. And this travel agent think now it's lower than 188. So we put the whatever we want to test. Wait, where's my pen? Yeah, here. So we put whatever we want to test in the bottom. Using this. Okay, this is what we want to test. So even though the average cost is 188, but in null hypothesis, it has to be opposite. So it should be this will be greater equal than 188. But if we set this, if we set it up as mu unequal to 188, then it's a different story. Okay, then it's two tail. But this one, she just want to show that the cost now is less. She think the cost is less. Okay, so we have to set a significant level. Alpha is 0.05 and it's one tail. Okay, so when alpha is one tail, and it's one tail, and this area is 95%. The T score, when we use the sample size 25, degree of freedom 24, the T score will be negative 1.711. Okay, so this is the critical T, 1.711, negative 1.711. So what we need to do is to calculate our X bar, the hotel average we survey, the 25 hotel, okay, minus the mu, and then divided by the standard deviation, and then divided by the n square, okay? So we got 177.5 minus 188, and then divided by the, this should be S, 25.4 divided by 5. Okay, so it's actually, the critical T is negative 2.07. It's actually smaller than 1.711. So that means we can reject the hypothesis, the null hypothesis. So that means the average is lower than 188. Okay, so you see here, this is here, so it's this. Okay, so according to the sample evidence from 25 hotels, there's enough evidence to support that average cost per night is now less than 188. Okay, but but we don't know where are what are those 25 hotels, right? If it's like star 1 or 2, then, or super 8, or different the other hotel, then it will be cheaper than Marriott, Hyatt, those kind of hotel, right? So from this we can really, from the numbers, yes, we can conclude, but it doesn't necessarily mean, oh, it's cheap to go to Chicago, not really. Yeah. So sometimes the numbers, they say numbers don't lie, but when people use numbers, people will manipulate numbers. So we need to be careful. So to use confidence interval approach. So since it's just only one tail, okay, so we will use the lower confidence level limit. Okay, so here everything is the same, but we need to calculate what is this when we convert it to the confidence level. Okay, so what we do is we use mu plus the T times the standard error of the mean. So it'll be 188 plus negative 1.711 times 25.4 divided by 5, square root of 25 is 5. So we get 179.31. So 179.31 is here. Okay. It's here. But our number is 177.5. So it's less than this. So both way, actually both calculations are the same. It's just, you see here, it's the same in same place, just different unit. There we use the average. Okay, here we use this number. There we use the t value. Okay, so that's the only difference. So again, we have enough evidence to support the average cost for the hotel is less than 188. So this one, oh, I don't have the I don't have the answer. So this one, you guys should try to do it, and then I'll go over this in class. Yeah. So so here, the Wall Street Journal claimed the average American watch 34.5 hours of TV every week. So you select 10 people and found out the average is 39.6. Standard deviation is this, and then alpha is 0.01, 02. So the confidence level is 98%. Okay, and it's a one tail or two tail. So it depends on what we want to prove, right? So if you think, oh, I don't think we only watch 34.5 hours of TV, I think it should be more than that. Or you say, oh, now people don't watch TV anymore. We just use our phone. Okay, so it should be less. Or we say, no, we don't agree with this number. It's probably, this is not accurate. So you can say, unequal. So whatever you decide, it will affect the critical value, because if it's one tail, then each side, one tail is 0.02. Okay, the confidence level will be 98%. But if it's two tail, it'll be 0.1, 0.01 each side. So it's still 92%, but one side is 0.01. Okay, for alpha, half alpha. Yeah. So here, so suppose, the example we use, suppose the viewing data recorded for blah, 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 blah. So we already have, so we found 10 people, and then this is 39.6, the sample mean, and then the standard deviation is 16.4. So the critical T determine, what is this? But here we actually want to test it as two tail. Okay, so mu is equal to 34.5, and then that's the null hypothesis, and then the alternative hypothesis, mu is not equal to 34.5. So the value for alpha equal to 0.02, and then we look at the degree of freedom is 9, and this is 0.02. So the T will be 2.821 plus minus, okay, 2.821. So we split into two tails, 2.821. So to calculate the critical T from the sample average is 39.6 minus this. So the critical T is actually 0.98, okay? So when we see 0.98, if you look at the chart, I like to look at the chart. So the chart is here, 0.98 is here. Okay, I don't know if you can see my mouse. Let me just get the pen. So 0.98 is here. And then the critical T is 2.821 and the negative 2.821. So all this area, we can reject the null hypothesis. Okay, so in this case, it's here. So that means we don't reject the null hypothesis. Okay, so our sample shows that 10 viewers do not provide significant evidence to reject the null hypothesis. Okay, so we have no conclusion. We have no evidence to conclude the average does not equal to 34.5. Okay, so that's it. And confidence interval approach. So again, similar to this, so we calculate the confidence level with the critical T, the T value, okay, 2.821 plus 34.5 plus minus 2.821 times 16.4 divided by square root of 10. So it's 49.1 and 19.9. So between 19.9 to 49.1, if it's within this range, then we will say, okay, the average hours is 34.5. Okay, we have to claim that because based on our sample size too small, so the margin will be bigger. Okay, so that's it. So, and then the population proportion, so very similar to the population mean, but we use P. So n times this pi is usually I say P, okay? So proportion data, it follows binomial distribution, either yes or no, right? Something happened or not happened. So the sample size times the P should be greater equal than 5, or sample size times Q, 1 minus P, greater equal to 5. So sample population is P. So the observation that this happened divided by total sample size. And then the Z score is P minus the pi, the population proportion, divided by P times Q divided by N squared. So let's use one example. So the proportion of cell phone user with 4G, I have to change it to 5G now. Last year was the average proportion is 0.62. And Verizon executive thinks the proportion already increased this year. So they did a sample of 350 users. 238 have 4Gs. So 238 divided by 350, that's the P, okay? So, and then we want to use alpha equal to 0.5. So what should we do? So first, let's use the critical Z, okay? And then first is to set up the hypothesis. So hypothesis is pi less equal than 0.62. Okay, it's not greater than this, but the executive think it already increased. So we say pi greater than 0.62. And then significant level is alpha is 0.05, and it's one tail. So the Z score for 95% one tail is 1.645. So this is 1.645. And now we just need to convert our P to the Z score. So to convert P is 0.68. So 0.68 minus 0.62 divided by the standard error of the mean is 0.62 times 0.38 divided by 350. So square root. So it's 0.06 divided by 0.026. That's 2.31. So if we go back to the chart, 2.31 is here, it's greater than 1.645. So in this case, we will not reject. We will reject the null hypothesis. Okay, so it means, yes, the average is greater. So the users with 4G is greater than, what was it, 62%. Okay. So it has increased above 62%. And then we use the confidence interval approach. So again, we know the Z value is 1.645. So we need to calculate this upper level limit, okay? So that will be P equal to pi plus 1.645 times the standard error of the mean, standard error of the margin. So this will be 0.62 plus 1.645 times, I think it's 0.026, right? So it'll be 0.646. So 0.646 is the proportion with the significant level 0.45. This is a cutoff. So anything greater than that, it means the average of 4G user increased for over 0.62, okay, 62%. So now ours is 0.68. So that means, yes, it's already over the current average, 62%. So that will be our conclusion. So this is another example. Let me see. Yeah, no answer. So 0.45. So this is two tail. So to tell 0.40105 is what? I think 1.96. So we can, let me get my pen. So we can use, let's just use the critical value. So it's what is it? 0.606 times 0.394. So that's that divided by 160. 60 and then square root. So that's one part. And we need to use that to times 1.96. Okay, is it? Oh, sorry. I should use, see, I'm still tired. So it should be 0.69 times 0.31. Yeah, because it should be mu. Go back. Is it one tail or two tail? Two tail, okay. Yeah, it should be mu, okay? So times that. Let me see, let me double check. Two tail is 1.96. This is, oh, this is now 95%. 8. Oh, what is this? I think it's 1.96. Let me check. Oh. Oh yeah, 1.96, 1.96. Is it? Yeah, 1.96 Z. Okay. So let's go back. So 0.96 times oops, what did I do? Okay, here. This, okay, times 1.96 will be, let me calculate it. I can't even find my calculator. Oh, here. Okay. 0.69 times 0.31 divided by 160, and then square root. So it's oops. Oh. Get my pen. So it's 0.037 times 1.96. So that will be 0.07. So it's 0.69 plus minus 0.07. So, oh well, I calculated the confidence interval, did I? Yeah, so if I use the critical value is 0.037, so it's smaller than 0.5. So let's calculate confidence interval. So it's 0.62 to 0.76. So if it's within this range, then that means it's it's equal to 0.69. But it is this is outside of the range. So that means we reject the that means the average is not equal to 0.69 anymore. Okay, so that means we reject the null hypothesis. So this is correct. This is supported. Yeah. Okay. So that's it for chapter 9. And I hope you guys would be able to like go through the last quiz, and then we'll go over, we'll review the test. Oh, I have to bring your test back. Well, I don't remember where I put them. Okay, so on Monday, I'll return your test. And now I have to find the test. Okay, bye.